Alright, so for this equation, I have 1 to the power of x plus 10 to the power of x is equal to 100 to the power of x. So, to solve an equation like this, what we have to do is we have to understand every term and how they relate to each other. So 100 is the same thing as 10 squared, so that's how they're going to relate. And 1 here, well, 1 usually, it doesn't make much of a difference to this entire equation because 1 to the power of any number is equal to itself. So for my solution here, what our first step can be is to simply rewrite 1 to the power of x as just 1. Because 1 to the power, x can be any solution, any value, and it would still, this term here would still be equal to 1 because 1 to the power of any number is 1. So now I have 1 plus 10 to the power of x is equal to 100 to the power of x. Now remember how I said 10 and 100 are related. 100 is the same thing as 10 squared. And it's always better to have a common base. So that's exactly why I'm going to rewrite 100 as 10 squared. So now I have 10 squared to the power of x. Now I'm going to use an interesting property of exponents. And this property states that if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So I can switch up the order of these two. So now I get 1 plus 10 to the power of x is equal to 10 to the power of x to the power of 2. From here, I'm going to let 10 to the power of x equal to the variable y. So now I have 1 plus y is equal to y squared. And this is something known as variable substitution, where you just input a variable for a term that at least appears twice. And this is just so we can make things a lot simpler, because now we can solve for y, and then once we solve for y, we can solve for x using that value of y. So from here, I'm going to rewrite this as y squared minus y minus 1 is equal to 0. And as you can see, what we have here is a quadratic equation. So to solve this quadratic equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So I now have two solutions of y. I have y is equal to 1 plus the square root of 5 over 2, and y is equal to 1 minus the square root of 5 over 2. So from here, we're going to go back where we let 10 to the power of x equals y. So if 10 to the power of x is equal to y, then this means that we have two equations here. We have 10 to the power of x is equal to 1 plus the square root of 5 over 2, and we have 10 to the power of x is equal to 1 minus the square root of 5 over 2. So for 10 to the power of x is equal to 1 plus the square root of 5 over 2, to solve this, I'm going to be using logarithms. So I'm going to first start by taking the log on both sides. So I have log of 10 to the power of x is equal to log of 1 plus the square root of 5 over 2. And now, the reason why we're using logarithms is because they come with the property that states that log a to the power b is equal to b times log a. So I can move x to the front, and now I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And log of 10 is just equal to 1. So I just get x is equal to the log of 1 plus the square root of 5 over 2. So this is one solution. And now if I go over here, well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal to a negative number. So there's no solution to this. So this is my only solution.